Okay, let's start. Hello, everyone, and welcome to today's Tech Talk on functional testing, chilled beams, and sales. My name is Sherry Adams, and I'll be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise and feedback throughout the presentation. We'll be using the Q&A function when we have a question. So if you can use the Q&A section, if you have a question, I'll be checking those throughout the presentation, and we'll have some time at the end for Q&A. We'll also be recording this Tech Talk, and it will be made available on the website under the resource section. There is a new password to get into those Tech Talks, so we'll make sure to send that out to all the members. Today's presentation is brought to you by the Southwest chapter, and today's presenter is Russell Ferry. Russell is a principal and mission critical director for engineering economics. He also drives commissioning process management services nationwide, supporting construction teams with test preparation before third-party commissioning. One of Russell's strengths is commissioning exceptionally complex facilities like data centers, clean rooms, laboratories, and hospitals. Russell's career started as a controls contractor and through the years progressed to branch manager role with a Fortune 100 controls service and equipment company. He's led over 110 projects since becoming a commissioning provider in 2009. His peers consider him an expert in control system integration and commissioning process management. He believes that commissioning is ever evolving and relentlessly pursues new methods and technologies. He's maintained that commissioning is most effective when the construction team prepares for the process. Based on commissioning up through the trades, he has a knack for connecting with CMs and ensuring that all work together as a team to resolve system issues before commissioning, facilitating a smooth process. Russell served on the Southwest chapter of the BCA for 8 years, including chapter president, and he is currently an international board member of the BCA. So welcome, Russell.
Thank you, Sherry, for that introduction, and want to thank everyone for joining us today as we talk about functional testing, chilled beams, and sales, and some best practices that we've learned in doing so on some recent projects over the last few years. The course description: attendees will learn some best practices for testing chilled beams and sales. Increasing popular newer technology, current designs, there are some best practices for properly testing the operation. We'll include some specification clarification for testing, requirements for the general contractors and installing contractors to pre-test, as well as I have a link in there from Titus from a chilled beam. It's a little dated, it's from 2015, but it's about 45 minutes long, and it's definitely a good resource as it relates to chilled beam and the emerging technologies from a manufacturer standpoint. Some system components. Installation, we're going to do a brief overview of the components involved with the chilled beam system. Installation in Europe and Australia for almost 18 years. It is an emerging technology in the United States. Installation starting within the last 13 years or so. Our company commissioned the first chilled beam project at University of Washington in 2014. And I'm going to be focusing on my experience with some recent projects that we've done at USC and 3 at Arizona State University in Phoenix, Arizona. We've got a few pictures here of active and passive chilled beams. On the left, that is a chilled sail that we used on a project, ISTB7, that we are currently commissioning. And that design is fairly new. We had to go to Europe for some examples of it being installed, and the owner had some questions about maintenance. So there really weren't any installs in the US. Passive chilled beam picture next to the right of that includes basically a coil, and it's a convector type system. And then we move to an active chilled beam where you've actually got some primary air and some coils. And then the pictures on the right are a couple of manufacturers of what the chilled beams look like. You also have a medium temperature chilled water loop. On this particular project, they're running about a 52-degree chill water, and it's a higher temperature chilled water to keep condensation issues and approaching dew point, and having it to where the chilled beams could actually rain down. So in this particular system, they've got a district energy loop and some heat exchangers in the building where they're maintaining that medium temperature chill water loop. Here's an up close picture of a chilled beam and kind of what they look like. We're working on a project right now. It's really cool from a color option. It's got a blue, kind of a teal blue. I didn't have a picture of it, but you can order them in a wide range of colors to match whatever the architect's design intent is. And then you've got an exploded view of what they look like as far as return air, any kind of wings and control for mounting and airflow diffusers, as well as coils and mounting options. They can either T-bar ceiling grid, grill face, or perforated face. Now, some design considerations and benefits. Installation cost is typically a little higher due to the need for more beams, but it is offset in the long run by energy savings over the life of a building. The advantage is smaller air handlers, smaller ductwork. They've got a lower primary CFM, higher discharge temperature, and a smaller footprint allows for more usable space. In the projects that we've done, they've been predominantly laboratory and research facilities. On the medium temperature chill water loop, there is a potential for higher pumping power cost, but less than respective if it was a traditional air delivery method. And then one of the design considerations that's a must is condensation sensors. So those safeties can either be local or zoned. We've had before where it is tied to each beam and the power for the chill water valve runs through that condensate sensor. And or it could be zoned to where you've got maybe a quarter of a building that's all looking towards a dew point sensor, and there's a software interlock or a hardwired interlock to a control valve for that zone to make it to where if we get to that dew point temperature, it closes the valve off. The projects that we've worked on have also been 4-pipe. One of the most recent ones is a 6-way valve configuration. That's the project that we're working on right now, and it has proven to be challenging, not only from the installing contractors, the mechanical contractors from a piping standpoint, getting it right, but also the setup and calibration of the valves has been challenging for the control contractor. And because they do share common return lines for, although a brief moment in time, there are different water treatment needs between the two loops. So I would recommend against a 6-way valve setup based on our experience that we've seen recently. Some of the commissioning challenges that we found on the projects is the laboratory controls contractor and the BAS contractor were different companies. And further compounded by the lab controls contract was held under the mechanical and the BAS was under the general. That led to a lack of coordination between the controls contractors and somebody that ultimately had the responsibility for providing a system that was functioning and pre-tested. We've also found that during startup and the issues that were identified, we started asking the controls contractor how they did startup, and many of them used a traditional probe type sensor or even an infrared gun, and neither one of those are accurate for properly testing chilled beams. Some lessons learned: testing specifications should require that the installing contractor use thermal cameras with certificates of calibration so that they can confirm proper operation. We've got a few examples of pictures on there. And then of course, we previously touched on it, having the laboratory controls contractor should be under the BAS controls contractor to ensure that someone has that final responsibility for functional control system and is coordinating an effort for a turnover of a functioning system. We've chosen the camera on the left. It's a Fluke. The cost on that when we purchased it about 3 years ago was $9,000. So they are kind of pricey, but it is cheaper than the FLIR in the middle, which that one's approaching about $18,000 in cost. And then there are some plugins for smartphones. That's the one on the right that are out there. They're around the $500 to $600 range. I have not used them, but I've had some peers that have used them in other applications, and so far they appear to be functioning like what we need them to. Another thing to keep in mind that you could rent these if you're not at a position that you're willing to invest. We did just from the sheer volume, we had over 1,500 chilled beams between 3 projects that it made sense for us to just purchase it. But there are costs involved with keeping that calibrated and certified at a minimum of $600 a year. And hopefully you don't need any repairs, which those can be more pricey during the calibration effort. Now, some testing methods and best practices. Pre-testing by a commissioning provider should include an initial pass using global commands to sweep the areas in the following conditions. So what we did is we walked through with the controls contractor and the general contractor and forced everything into a dead band. The building that we were doing was a 270,000 square foot, 5-story, and within a full day, we were able to walk through the entire building in all 3 modes of operation here. So if you look at that top picture, this is strictly just scanning the ceiling for kind of an initial verification and a sanity check that everything's at least appearing to be functioning like it should. So we'd go through and force everything into a dead band, go through and shoot the ceiling. Anything that wasn't functioning, the controls contractor and general contractor took notes and they went back and addressed them prior to us doing our full point-to-point verification. And then in cooling mode, you can see where everything is forced into full cooling globally, and you can walk through and actually see the chill beam radiating kind of a blue color and a temperature that indicates that it is in cooling mode. And then same in the heating mode. Here's a picture of a graphic from the BAS system that kind of shows what a typical lab system looked like on this particular project, where you had a VAV box that's providing primary air and then some chilled beams in the space that were maintaining the temperature of the space. Now, some issues noted. During our initial testing, we found that they had some crossed wiring in zones, points that were not mapped correctly, valves not closing off completely. And we've got some pictures here that we'll go over kind of left to right. And it kind of highlights the need of why you have to have an infrared camera to do this, to properly test the system. So on issue number 34 on the top left, we found that when it was in heating mode, they weren't actually getting adequate heating. They had an issue with the valve on that particular one. And then the one right below it was in heating mode, it wasn't really flowing like it should. So again, it would be hard to tell that that system's not functioning. And a couple of these arrangements, the way they were set up is they had 3 beams in a space. So they were maintaining temperature in the space based on the BAS controls. But when you were doing the individual beams, we had instances where the beam in the middle was not functioning, but the other 2 beams were still keeping the space comfortable. And it wasn't known that that's what the issue was. Issue number 21 there, the heating valve was open during cooling mode and closed during heating mode. That was just some valve signals that were swapped that would have been caught had they done some pre-testing with an infrared camera. The next one we had kind of the same thing, the one right below that, issue number 22, no chill water flow during cooling mode. And we had chill water flow during heating mode. So they had some valves swapped, not even tied correctly within the BAS system. And moving on to the right, there was an issue where in deadband mode, the heating mode was controlling backwards. And we actually had some heating coil flow in the cooling mode. So it was simultaneously heating and cooling at the same time. And then the one below that was in heating mode, no cooling, or no heating at full cooling. And then finally to the right, kind of another instance where we were simultaneously heating and cooling in a portion of it. And then some commands that were backward within the control system. It all leads to ensuring that there's proper checkout and pre-functional checklists for people to fill out that they are thoroughly checking the system prior to commissioning beginning. And then in future maintenance, it's suggested that an annual scan of the beams be completed using global commands at the same approach, just to ensure that the system's functioning like it should. And with that, any questions? Sherry, are you monitoring the Q&A?
Yes, it looks like we have it's not really a question, more of an observation. It says, we've seen that the 6-way valve install on recent projects here in Spokane, they utilize a moisture sensor on the chilled water return. The manufacturer recommends the moisture sensor is installed in the conditioned space, which poses an issue with duct return systems, or when the 6-way valve is located outside the conditioned space, i.e. the corridor instead of in the room.
Gotcha. Yeah, that's an observation. Thank you, Dominic. We found that too, and I don't know if it's been on your project as well, the control contractor has had a really tough time properly setting up a 6-way valve and even understanding how it functions, to where it impacts system performance, and it has led to them going through the system almost twice to properly set up a 6-way valve.
Looks like there's another question, says, did you find any instances where the VAV was fighting with the chilled beams?
No, in the particular project that we had highlight on there, we had not seen any issues. Our approach was to do the VAV testing prior to the chilled beam testing so that we could make sure that the upstream air delivery was functioning per the sequence of operation. So we did not see any of that, but the potential is there. If you're just looking at a chilled beam and not looking at anything from a primary air standpoint, it kind of helps identify what the approach should be. Is air handler down to VAV to chilled beam would be the process to ensure that the end device is functioning like it should.
Okay. Another question, please discuss strategies to eliminate the need for intermediate temperature cool water.
Strategies. I might need a little bit more information on that one. You can't really eliminate it. You can't have, 42-degree water going to a chilled beam. You'd have condensation issues within the space. That's why you have to have a medium temperature loop where you're controlling. On most projects, it's been anywhere from 52 to 56 degrees to make sure that you're not at that condensation point and creating issues with the condensate. I hope that answers the question.
Okay, and then another question, do you put the dew point sensor in the space or the duct?
I would definitely be in the space. There are times where it can be a sensor that's mounted on the wall, or it could be up above the ceiling or on the return line for the medium temperature chill water. The duct at this point is not a place where you'd put it because you're actually looking for zone conditions. You don't want to have it to where you've got a dew point condition and actually raining out of the chilled beam.
Okay, let's see. There's another question. Were there problems with the 6-way valve due to mixing? And did the designer neglect to take this into consideration?
Yeah, I wouldn't say neglect. I would say that the designer, this was a new concept for them with a 6-way valve, and it was new for the client and myself personally. I don't think that it was realized the complexity of a 6-way valve, not only from the traditional standpoint of a mechanical contractor being able to pipe it up, but also the controls contractor having the technical ability to properly start it up. So that's why I would suggest against it. The other project that we did with chilled beams that was sizable just had predominantly 2-way valves, and it was a 4-pipe traditional system.
Okay, let's see. Another question. Do you have any issues with condensate sensors? In past systems we have commissioned, we have found the sensors to be troublesome with a lot of nuisance alarms and also cannot be properly tested. Have you had experience with using room humidity sensors to calculate dew point instead?
Yeah, that's a great question. We found that there were some issues during startup with condensate sensors. Those were fixed and we didn't have any repeat or failures after they were. There are opportunities that you could use a room humidity and calculate dew point. Then you're kind of reliant on the network to pass that information along. So you're kind of shifting it from a sensor that's potentially local, that is your safety, to something that you're relying on a calculated value within the program and it transferred across the network to do your safety. So it could be done either way. Of course, I would lean towards having something that's a little more localized and a little more of a safety type, hardwired safety. But there are opportunities that you could do that under programming for sure.
Okay. All right, another question. Are there situations where you have a hybrid building system type where you need to run medium temp CHW and low temp CHW? And how would you handle the design in that case?
Yeah, good question. We do have low temp chill water at the air handler level, but for a chilled beam install, no, you wouldn't have what we would consider historical 42-degree chill water going to a chilled beam. So in this particular building, we do have a district energy loop that takes care of chill water to fan coil units, air handlers, things along those lines. But as it relates to an actual chilled beam, that's a separate medium temp loop that's got a separate heat exchanger and control system.
All righty, let's see. Can you advise maximum cooling? I'm not sure per tonnage. I'm not sure per square foot. I'm not sure if you see that question.
Tonnage. Yeah, no, I'm pulling it up right now.
Okay. I just wanted to make sure I was using the right terminology.
You're good.
Okay, so yeah, so can you advise on the square foot requirement above which chill beams are likely not a good solution?
Gotcha. Yeah, the envelope is the key to this. You would not want to have a chilled beam solution in a building that doesn't have a tight envelope. We've found that, or high humidity, that's the other issue, is the high humidity environment with a building envelope that is not tight could create a really big issue. And when you look at that link that I had for Titus, as they are talking about design considerations, they do go in depth into calculating the cost per square foot, the tonnage per square foot, and what some of the limitations are of chilled beams. In our climate in Arizona, it is a great cost-effective way, but we don't have to deal with high humidity environments.
Perfect. Okay, and then let's see, we've got please discuss new chilled beams with onboard condensate capture.
That is a new one for me. So that's something we could definitely follow up with, Doug. Everything we have done have been the chilled beams that we've talked about. If you're designing and installing a chilled beam system, you typically don't have condensate. And if you did, it would be minimal. In that Titus presentation, they talk about where they've got a potential, and they use a classroom as an example, where it's almost like a convection type radiator that sits up against the wall, where they've got some condensate capture, but a chilled beam is not something that you would have a design for condensate capture. You'd need a different application if you're expecting that you're going to have condensate off of it.
Great. And then have you seen any moisture sensors for pipe that work?
We have. I've got some people that have done that. I don't have what brand they were, but I could definitely follow up with you, John, on that one for the ones that we actually used on the most recent projects.
And let's see, it looks like we've got a couple more here. Was this simultaneous heating and cooling a piping issue or controls, and how is that addressed by the contractors?
was not a mechanical issue. It was definitely a controls issue. They had some valves that weren't properly seating, or we had where they actually had some swapped wiring as well. So they thought they were controlling the heating valve, but it was actually the chill water valve. Again, proper checkout would have caught a lot of that. These are pretty simple systems when it comes to the functionality of them. So you're really not going to have any kind of mechanical failure on them. It is typically controls or controls related, or maybe some debris in the seat of a valve.
Okay, it looks like we have a few more here. Please discuss keeping the coils clean. How often should they be cleaned? How the overall system air quality, floor finishes, and custodial practices impact beam coil and grill cleanliness.
Yeah, definitely. Good question, Doug. We have found that based on manufacturer data, our oldest install is only about 3 years old that I've been involved with. But when we asked that same question when ASU was pursuing this new technology, the manufacturer came back and said that it's about every 3 years that they're going to need to clean the coils and just do a regular preventative maintenance type service on them. It involves, especially on like the sails and the face, where you could just wipe it down with a rag, and that usually is what you need to do to clean it. But definitely need to keep in mind minimal dust within the space and making sure that a PM routine is set up for the future maintenance of a chilled beam.
Okay, and then it looks like we got one last question and then a comment in the chat. So this question we have is, would there be a higher chilled water temperature on the East Coast where OA humidity is much higher?
Definitely. I mean, it's all based on dew point. It'd probably be a lower chill water so that you could help wring some of that moisture out. But again, the envelope in the building as a whole is the key to making sure it's the right application for your building.
Okay, thank you. And then it looks like the, Russell, just a comment, the link for the YouTube, the Titus YouTube link is not working. So I don't know if we could get an updated link out to the attendees for after, or we could just put it in, if we need an updated one, put it into the presentation.
Yeah, I can definitely do that. I just clicked on it this morning, so I don't know why it's not available, but we could definitely make sure that that is updated and in the presentation that we're going to publish so that everyone's got access to look at it.
Wonderful, wonderful. Okay, well, and just one last comment or announcement to all that on the call, that the BCA annual conference is in Glendale, Arizona this year, September 21st through the 23rd, and registration will be opening up later this week, so keep an eye out for an email announcement with the registration. And with that, I think that is all. On behalf of BCA, I would like to thank everyone for your participation today. And Russell, thank you so much. We appreciate your time and expertise.
Yep. Thank you. Thank you, everyone. We hope to see you at the conference this year.
Thank you. Have a great day.